Evaporation. What is evaporation? So if you remember again the crisscross chart, the transitioning of the liquid state to the gaseous state is known as evaporation, and the vice versa thing, that is the transition from the gaseous state to the liquid state, is condensation. Let's first of all learn what is evaporation. Change of a liquid into vapors at any temperature below its boiling point is called evaporation. Change of a liquid into vapors, yes, at any temperature below its boiling point is called evaporation. Now this is very interesting because we had earlier we have been earlier learning that when heat is applied to liquid and when liquid changes into gas, okay, this process called vaporization, we were applying heat. But evaporation, what is evaporation? Evaporation is happening not at the boiling point, it is happening at any temperature below the boiling point. So basically there is no extra temperature that you are adding, okay, there is no extra again force that you are adding to make this process happen, but still it happens. Why does it happen? Let's see. Example, water when left uncovered slowly changes into vapor and wet clothes drying up. The easiest example to follow is that when you wash your clothes and when you hang it, so when you hang it, what is happening? You're letting that wet cloth dry up in the air to dry under the sun, right? So after a while, that water droplets that are there on the surface of the cloth, that wet water droplets, they will by then transition into the water vapor state. And for that to happen, you need not apply that 100 degrees Celsius of temperature to your clothes or to that water. It just happens on its own. It happens at a temperature that is below the boiling point, and this process is called evaporation. If you even take a small cup of water and you leave it uncovered for a few days or for a few hours, you may notice that slowly the level of water that you had taken earlier, it will reduce because at the surface, what is happening? Evaporation is happening and water molecules are changing into the gaseous state. How this happens and why this happens, we'll see. How evaporation takes place. In case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles and gets converted into vapor. What is happening here is that at the surface of the liquid, there are a small fraction of particles, okay, at the surface that have higher kinetic energy. Why? Because so you see, if there is, suppose this is a beaker of water, okay, and there are particles of water like here, and there are particles of water at the surface. Basically what happens is, for these water molecules that are at the bottom of the beaker, they are all surrounded by particles of water, but the particles of water at the surface, they are only surrounded by particles of water that are immediately below them. Above them is the open surface. Above them there is no liquid state that they are in bond with, right? So in comparison to these below particles of water, the above ones, they have higher chances of breaking away from the water bonds, from the force of attraction, and they have the higher chances of getting converted into the gaseous state. So this is why for the evaporation to take place, the boiling point is not necessary to be reached. It can happen below the boiling point because basically the water molecules at the surface, they're trying to break away from the other water molecules, because particles by the nature, they have the tendency to roam about freely, okay, with high kinetic energy. So because of that, they're able to break free and they're able to move around and being converted into vapor. Factors affecting evaporation. Now there are certain factors that either increase the process of evaporation or decrease it. What these factors are: rate of evaporation increases with an increase of surface area, an increase of temperature, a decrease in humidity, and increase in wind speed. Why this happens is because if you like in this diagram, there is this small beaker of water, right? But if you take a small cup of water and if you keep that small beaker of water and the small cup of water in a particular area, you will notice that the decrease in the level of water will be much quicker to be seen in that small beaker as compared to the cup, because the surface area of the cup is not very high, but the surface area of the beaker is very large. Okay, owing to its large surface area, so the large amount of water molecules, even though the quantity is same, but because the area is larger, so more water molecules would get the chance to break free from the water molecules that are below them. And because in a cup the surface area is not so high, okay, so they will not get the chance, not all the water molecules will get a chance to increase into transition into the vapor state more quickly. Increase of temperature, it's a very easy phenomenon, right? Because when you increase the temperature, you are basically supplying more kinetic energy, so you're basically giving an opportunity to the liquid state to transform into the gaseous one. A decrease in humidity. Humidity is basically the amount of water molecules that are present in air. So if air molecules already have certain water molecules present between them, right? This is humid. So if suppose this large particle is the air particle, okay, whatever gases in the air might be, and these small other water vapors, okay. So what is happening? All of these, both of these, they're in the gaseous state, okay. But since the air already has some amount of water vapor inside it, uh, if you want to let a certain amount of water be vaporized, the speed, the rate of that evaporate, the rate of that evaporation will be decreased because humidity is already there. Okay, so but when that humidity is less, when there is not water vapors present um, in the air molecules, so the rate of evaporation will be increased because this evaporated water vapor, these evaporated gaseous water vapor will get into the chance to be, incorporated, assimilated between the air molecules. Okay, so a decrease in humidity increases evaporation. Increase in wind speed. So what is happening is that when there is an increase in the wind speed, the air, as you know, is it a fluid? It is a fluid. It has the property of, flowing continuously. So when there is an increase in the wind speed, the air from one area is quickly flowing to the air of the other area. So if you were to evaporate something from some liquid, okay, so the rate of evaporation will be increased, because even if there were water vapors in a certain area, because of the increase in the wind speed, other molecules of air which probably do not have that high amount of water vapor between them, they will be coming, they will be, flowing. Because of the continuous movement, that continuous flow, there will be an increase in the rate of evaporation. Effect of surface area. So it's basically we'll be now learning about what I have already told you here. All these factors, how do they affect? Evaporation is a surface phenomenon, like I told you. So if the surface area is increased, the rate of evaporation increases. Same as I told you in that beaker and the cup experiment. Okay, because the surface areas of the beaker is high, so water will evaporate more swiftly. For example, while putting dry clothes for drying up, we spread them out. Yes, this is another very important thing to remember. When you dry clothes, so if you spread the cloth, if so, you can do this at your home. You can take a piece of wet cloth and you can just keep it like that, hang it like that on the rope, or you can take another piece of cloth and you can spread it out as far as you can. What will happen is that in that spread it out wet cloth, the water vapor, it will evaporate more easily as compared to the one which is not spread, because again it is getting more surface area, so it is getting more particles of water getting the opportunity to being converted into the gaseous state. In this diagram also, evaporation through small surface, it's not happening so quickly as compared to the evaporation through a large surface. Effect of temperature, like I told you that with increase of temperature, more number of particles get enough kinetic energy to go into the vapor state, hence evaporation increases. Effect of humidity, so humidity, like I told you, is the amount of water vapor that is present in the air. So the air around us cannot hold, yes, this is a crucial thing to remember, the air around us, it cannot hold more than a definite amount of water vapor at a given temperature. So at a given temperature, there are only some amount of water vapor that air can hold. That is why in India, in the rainy seasons, there is a high amount of humidity because already because of the summer and everything that has passed in the previous season, a lot of water vapor has already been evaporated, and all of them they are already present in the air. So the air already has a huge amount of water vapor. That is why when you feel hot in the months that we are in the months of August, July, September. Okay, in these months, when you sweat, your sweat does not evaporate. Sweat is also liquid, right? So sweat is not evaporating faster in these seasons because air already has a fixed amount of water vapor, and it cannot hold more. That is why you feel more sultry. So if the amount of water in the air is already high, so the rate of evaporation decreases. Effect of wind speed. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in surrounding, hence evaporation increases. So like I had told you, if the wind is continuously moving, so what is happening? The wind is continuously moving, continuously all the particles of air, they are getting, even if it has water vapor, they are flowing, right? So the particles of air which have low amount of water vapor, so they will get the chance to flow around, and the rate of evaporation is increased. How does evaporation cause cooling? This is an important phenomenon. In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surroundings um, make the surroundings cold. What is basically happening is that for the evaporation to happen, you are not applying any external heat. You're not applying any external amount of temperature, right? Still, the water particles they are able to evaporate. They are able to transition from the into the gaseous state. Now, since evaporation is a surface phenomenon, so what is happening is that water molecules over here, if you may, they continuously absorb energy from the surroundings. So whatever air or whatever element is there in their surroundings, these water particles they are consuming energy. They're consuming energy in order to break this intermolecular force of attraction, to break this intermolecular bond, so that this particular water vapor can be converted into a gaseous state and can move away freely. So in the absence of an external temperature, in the absence of external heat, these water particles they are taking energy from the surroundings, absorbing that, using it to break the bonds, and using it to break free and transition into the gaseous state. So this absorption, so what is happening if the energy in the surrounding, if the water particles are absorbing those energy, that is they're absorbing heat basically, right? So after they have absorbed heat, the surrounding area would be comparatively cooler as it was before, because some amount of heat is taken up by the water molecules or by the liquid particles in order to evaporate. That is why the area after the evaporation has happened, the area is comparatively cooler. Why we feel cool when acetone pours on our palm? The particles of acetone is the nail paint remover, they gain energy from palm or surroundings and evaporate, causing the palm to feel cool. So when you pour a few drops of acetone on your palm, so basically the liquid droplets of the acetone, they are absorbing the energy from your palm, and they are using that energy to convert into vapor. Okay, and because they are taking energy from the surface of your palm, so you feel cool when you pour some particles of acetone on your palm. Why should we wear cotton clothes in summer? Important question. During summer, we perspire more because of the mechanism of our body which keeps us cool. So during summer, we perspire, sweat toxins and all the other things are removed, and it is a mechanism by which our body keeps itself cool. So during evaporation, the particles at the surface of the liquid gain energy from the surroundings or body surface and change into vapor, leaving the body cool. So cotton, being a good absorber of water, helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. What is happening here is when you wear cotton clothes during summer, all the heat, all the toxins, the sweat that is coming out from your body, cotton absorbs those sweat, okay, and that is, it basically makes those sweat, those liquid particles to be available to the surrounding. So what happens is that if so what happens is that if you wear a cotton t-shirt, so basically what is happening, the sweat molecules that are getting, you know, drenched onto your cotton cloth, the cotton makes these molecules available to the surroundings, so that, you know, it can take energy, so that it can take energy and it can leave its liquid state into the gaseous state, and it can cool the body down. So it's basically taking up the heat from your body, also from the surrounding, but mostly from your body, since the sweat is on your cloth. So it's taking up heat from your body and it's using to transition into the gaseous state. So as a resulting incidence, you feel cold, you feel cooler. That is why it is apt to wear cotton clothes, because they make this process more easy, right? They make it convenient. Whereas other clothes, such as synthetic or silk or any other clothes, they do not expose the sweat. They do not absorb the sweat and expose them to be converted into vapor. Cotton is the best in this. So that is why it is recommended to wear cotton clothes in summer. Why do we see water droplets on the outer surface of a glass containing ice cold water? Now, the water vapor present in the air, on coming in contact with the cold glass of water, loses energy and gets converted to liquid state, which you see as water droplets. So if you, it's a very common thing to observe. So if you take a very chilled water from the fridge, or if you take very chill cold drink and you pour it in a glass, okay, so what happens after a few seconds, you will observe that small water droplets are getting collected on the glass. What is happening is basically the water vapor that is present in the air, they are coming in contact with the cold glass of water, okay, and these water vapor that are these water vapors that are coming in the air, that are present in the air and coming into contact with this cold glass, this water vapor, they are absorbing energy from this cold, from the surrounding, from this cold glass, and they are using this energy to basically convert into the liquid state. So basically it is basically giving its energy instead of using it. So basically what happens is liquid to form into a gaseous state, liquid to form into a gaseous state, liquid to form into a gaseous state, what happens is that they absorb energy to form into the gaseous state. But in order for the process to be reversed, in order to gas to form into a liquid, they give out heat, right? So when water vapor, they get when they come close to this glass of cold water or cold drink or whatever it is, okay, so they're basically losing their heat to the surface. That is why the gaseous state of water vapor is being converted into liquid and you're seeing the small droplets of water. Whereas since they are losing heat, the cold water, cold drink, whatever was there in the glass, the cold substance is gaining energy, and so its temperature it increases. Question 1. Why does a dessert cooler cool better on a hot dry day? So yes, this is an easy thing. So what happens in a cooler is that the air, the turbine, a small fan is basically there in a cooler, and it keeps on rotating. Okay, it keeps on rotating, and it converts the liquid to gaseous state so that you get the cool air. So what is happening on a hot dry day? There is already, the important thing to remember, that it is hot plus it is dry. Dry meaning there is less amount of water vapor present in the air. That means the humidity is less. So what happens that when the cool air is pushed out of the cooler, okay, so it is very, when the liquid state is converting into gaseous state, okay, so it can happen very easily. Okay, and because of the less humidity, it is also very easy. So because there is, the air is less humid, and because the air fan in the cooler, it is continuously moving. So what happens to the liquid? It is basically the air fan is transforming its heat. It's transforming its heat to the liquid in the cooler. So when the heat is transformed to the liquid in the cooler, the liquid, they gain the kinetic energy and they are basically being evaporated. They are basically being converted into the gaseous state. So in being converted to the gaseous state, they are coming out of the cooler, they're giving cool air, because even though the temperature is increased, that is basically used to change the state of matter, and the cool air is giving out coming out of the cooler, and it's coming out in a functional way, in a very efficient manner, because it is a hot dry day. So there is already less amount of water vapor present in the air. So the more amount of cool air that is coming out of the cooler, it is easily getting spread in the surroundings all around you on a hot dry day, and that is why a desert cooler cools better on a hot dry day. The second question is, how does the water kept in an earthen pot or a matka become cool during summer? This is also a very interesting thing. So what happens in an earthen pot is that, pardon my drawing, um, if this is the amount of water that you have kept in an earthen pot, so this earthen pot is basically made up of clay, mud, and if you recall it, if you observe that clay or mud is not very, the consistency is not all sort of, it's sort of porous, not so porous as a sponge or a cotton would be, but still it is porous in nature. So because of it being porous, there are some water particles that seeps through the small pores. There are some particles that seep through the small pores of this earthen pot. So what is happening is that these water particles, they evaporate. And how they do so? Because these small water particles are, they are sort of peeping out through the earthen pot. So all the particles want to break free, as I told you, right? So these water particles, they absorb the energy from the immediate surrounding. And what is the immediate surrounding? The water that is already present in the earthen pot. So when these particles, they absorb energy from the water in the matka, and they transition into the gaseous water vapor state. So they are basically absorbing heat, and because they are absorbing heat, the remaining water in the matka, it is comparatively cooler now, okay, because it has lost its heat to the particles of water that were at the surface of the matka, and that is why water kept in an earthen pot becomes cool during summer. Why does a palm feel cold when we put some acetone or petrol or perfume on it? Now we have already seen this earlier. I'll be explaining you again. So what happens is, when we put some acetone or petrol or perfume on a palm, these these liquid particles, they have a very high tendency to evaporate. So immediately as they are poured onto your palm, they absorb heat energy from your palm and they evaporate into the gaseous state. And because they have absorbed heat energy from your palm, that is why you are left with a cool sensation. Question 4. Why are we able to sip hot milk or tea faster from a saucer rather than a cup? Now, it is, as I have told you, that evaporation is a surface phenomenon, and the rate of evaporation increases when there is increase in the surface area. So the surface area of a saucer is definitely higher than the surface area of a cup. Okay. So because of the surface area of a saucer being higher than that of a cup, so when you pour milk, tea, water, anything over here, the rate of evaporation between the molecules, liquid molecules, it is higher. Okay. So because the rate of evaporation is higher, the saucer part, the milk or tea that is in the saucer, it will cool faster as compared to the cup. Why? Because all the particles, they are basically absorbing energy from the particles that are below them, absorbing energy, transitioning, evaporating into the gaseous state, leaving the remaining milk, tea, water, whatever the liquid you pour onto it, leaving them comparatively cooler.